Hello and a very good morning. My name is Muhammad Raikal bin Muhammad Liza, now metric DF22094. Now I would like to present about the introduction. The Mackintosh probe invented by a Scottish is useful in geotechnical engineering to determine soil density and the load bearing capacity. It is useful in areas such as the design of the foundation and the construction of road, consisting of drive road, steel cone, manual handle, hammer, and connector road. It function by driving the cone into the soil with the number of blow required for deep measurement. Then, the most general use of the Mackintosh probe test (MPT) is establish the soil bearing capacity, which is the vital of the design and construction of foundation for construction project. It is entail the use of a weight hammer to drive a steel rod with a point end into a ground to the depth of 30 centimeter and accounting the number of blow required. This measure of resistance gives the measure of the strength and compactness of the soil. Then the last one is fieldwork involves ground investigation, which is involves physical assessment and ground condition at site where the construction is undertaken through site inspection, taking of soil sample and conducting in situ test. Strength permeability, compressibility of the soil and rock sample are measured in
So I will
laboratory.
talk about the Mackintosh probe test, MPT, which is also known as John Mackintosh test. So for the overview of this test, it is a simple field test in geotechnical engineering where it is to determine the strength and bearing capacity of soft soils such as silt and clays. Next one is this test is cost effective, which is it is inexpensive method for assessing soil qualities and also essential for civil engineering structures to like foundations and embankments. Next one is the test procedure, which is it uses a small probe weighing around approximate 2.5 kilogram. Probe is dropped from a height about 50 centimeter and the number of blows required to penetrate 15 centimeter into the soil is recorded. So there are a few data we gain from the test, which is the condition of subgrade, soil density, shear strength of the soil, and the bearing capacity. So there are three objectives of this test. The first one is to examine the applicability in civil engineering. Next one is to assess soil characteristic with the prop test, Mackintosh prop test. And the last one is to discuss the application of the test. So for the scope of study, the first one is project planning and site selection, equipment preparation, field testing procedure, data collection and logging, data analysis and interpretation, and the last one is reporting and documentation.
Okay, for the impact of Macintosh probe test, first of all, is the advantages of the test. It provides a rapid determination of the soil property. It is also used in cost-benefit analysis, especially in areas of operation. It is easy to operate, and the procedures of data collecting and analysis. It also enhances the understanding of the soil variability between the 2 points. For the disadvantages, it is vulnerable to human error, including wrong blow counts, wrong drop height, and poor vertical positioning during operation. It is also only effective in the shallow layer of the soil. Its operation depends on the user master strength, which will affect the result of the test. The manual handling can prove to be hazardous for humans. After that, the next impact is for the limitation. While the Macintosh probe test offers several advantages, it does have limitation. One of the significant drawback is its sensitivity to varying soil condition and obstacles like rocks or roots that can impact the accuracy of penetration resistance measurement. Moreover, it may not provide the detailed data necessary for complex engineering analysis. Lastly, its effectiveness can be diminished in soil with high moisture content or where soil layers are highly heterogeneous. Despite these constraints, when it is used alongside other soil testing methods in a thoughtful manner, Mackintosh probe test remains valuable for initial site investigation and for quickly assessing soil and consistency.
Hi, I am Muhammad Nuriskandar bin Mahathir. I will explain about our case study, the correlation between soil erodibility and light penetrometer blows, a case study in Sungai Langat, Malaysia. Today, I am excited to present findings from a research study on the correlation between soil erodibility and Mackintosh probe blows in Sungai Langat, Malaysia. This study explores how soil compaction, as indicated by Mackintosh probe blows, correlate with soil erodibility across different land uses in this region. Let's start with a brief overview of soil erosion and its significance. Soil erosion poses significant challenges to agricultural productivity, water quality, and environmental stability worldwide. Understanding soil erodibility, which refers to the susceptibility of soil to erosion based on physical properties like texture, structure, and organic content, is crucial for effective land management and conservation. The Mackintosh probe, a tool used extensively in soil science, assesses soil compaction by measuring the blows required to penetrate the soil to a standard depth. This method provides a rapid indication of soil density and potential erodibility, complementing more detailed soil analysis techniques. The primary objective of this study was to assess the relationship between Mackintosh probe blows and soil erodibility, which is K factor in Sungai Langat, Malaysia. Sungai Langat was selected due to its diverse soil types and land uses, which allowed for comprehensive analysis across various environmental conditions. To gather robust data, researchers conducted systematic soil sampling across multiple locations in Sungai Langat, ensuring representation of different land uses such as agricultural fields, forests, and urban areas. Soil samples were collected using standard protocols, preserving soil structure and composition for laboratory analysis. In the laboratory, soil samples were analyzed for particle size distribution using sieves and hydrometers, organic matter content using loss on ignition method, and other key soil properties relevant to erosion susceptibility. Concurrently, Mackintosh probe assessments were conducted in the field to measure soil compaction at each sampling point. Mackintosh probe, as we know, consists of stainless steel rod with a conical tip designed to penetrate the soil under controlled hammer blows. Each blow correlates with the resistance encountered, providing an empirical measure of soil compaction. This method is favored for its simplicity and efficiency in assessing soil density compared to traditional penetrometer method.
Next, my name is Farhan Fazrik and I will be presenting about the result and soil properties. Variations in soil properties across different land uses in Sungai Langat. Influence of soil structure and composition on erosion susceptibility. There are samples which are 1A, 1B, 1C, all the way until 4C. The clay composition, silt composition, sand composition are recorded. There are also textural class of the soil. Next is soil erodibility K factor. Calculation and interpretation of K factor values based on soil properties and Mackintosh. The K factor values for samples 1A until 6A are calculated. Correlation analysis. Strong positive correlation between Mackintosh probe blows and K factor values. Implication for soil erosion risk assessment and management practices. The correlation analysis revealed a significant relationship between Mackintosh probe values and the K factor. Generally, soils with higher penetration resistance, higher MP values, tended to have lower K factors, indicating lower erodibility. Conversely, soils with lower penetration resistance showed higher K factors, indicating higher susceptibility to erosion. Next is the application. The Mackintosh probe Figure 2.1 is a small, lightweight, and easily transportable penetrating tool featuring a cone with a base. The advantages of Mackintosh probe are speedy operations, low cost, accessibility to difficult terrains, and simple data recording and analysis. In this study, The Mackintosh probe values were recorded at every 100 mm increment for each layer.
These findings from the case study have significant implication for soil management and conservation strategies in Sungai Langat and similar regions. Effective soil conservation practices such as contour farming, cover cropping, and reduced tillage can help mitigate soil compaction and erosion risks identified through Mackintosh probe assessment. Limitation of the study include sample size variability and seasonal variation in soil condition, which may influence the accuracy of erosion prediction. Future research could explore this factor in greater detail and extend the study to include long-term monitoring of soil dynamics across different climatic conditions. In conclusion, this study highlights the critical role of Mackintosh probe in assessing soil compaction and its correlation with soil erodibility in Sungai Langat, Malaysia. By integrating field observation with laboratory analysis, researchers have provided valuable insights into soil erosion dynamics that can inform sustainable land management practice.
Then the last part is conclusion. This work sought to establish a link between soil erodibility and market crop value, providing a practical alternative to existing soil sampling producer that are time consuming and labor intensive. Using the Mackintosh probe, which is offer a rapid field data, the study aimed to simplify soil erodibility evaluation, saving time and money. Then the correlation should be refined further, underlining that need of strengthening to the dataset by adding a broader range of soil series and increasing soil property assessment accuracy. Using the Mackintosh probes, quick result and refining correlation with comprehensive data, this work proposed a potential path of efficient and particular soil evaluation, especially in field circumstances when time and resource are restricted.